children, let us study the structure of carbonyl group. Carbonyl group, we know that C double bond O. In aldehyde, the carbonyl carbon, this carbon atom is bonded to a hydrogen and an alkyl group. In ketone, carbonyl carbon is bonded to two alkyl groups. The C double bond O carbon atom is in sp2 hybridization. Double bonded carbon atom we have studied. Double bonded carbon atom undergo sp2 hybridization. Means carbonyl carbon is sp2 hybridized. How sp2 hybridization? Let us write the electronic configuration of carbon. Atomic number 6, 2s2, 2p2. This is the ground state electronic configuration. In the excited state, what happened? One of the 2s electron get excited to the empty p atomic orbital, so that the configuration becomes 2s1, 2p3. Now, out of these 4 half-filled atomic orbital, 3 would undergo sp2 hybridization, producing 3 sp2 hybrid orbital. So these 3 sp2 hybrid orbitals form 3 sigma bonds. One with oxygen, the other one with a hydrogen or carbon. So 3 sp2 hybrid orbitals would overlap with the atomic orbitals of oxygen, hydrogen or carbon atom and form 3 sigma bonds. Trigonal planar, 120° bond angle. Now see the 4th unhybridized p atomic orbital that is present in carbon, which is perpendicular to the sigma plane. If this is the sigma plane, this unhybridized p atomic orbital is perpendicular to that plane. Here in oxygen atom, see oxygen atom, the electronic configuration, oxygen atomic number 8, 2s2, 2p4. 2p4 configuration means first p orbital fully filled, the other 2 are half filled. One of the half filled p atomic orbital on the oxygen atom lie perpendicular to the sigma plane, and that is parallel to the p atomic or unhybridized p atomic orbital on carbon atom. So these two will undergo sidewise overlapping or lateral overlapping. These two half filled p atomic orbitals which lie perpendicular to the sigma plane undergo parallel overlapping and form the pi bond. So in C carbonyl group, C double bond O, one is sigma bond, the other one is pi bond. So here C O, this is the sigma plane, and there would be a pi cloud above and another pi cloud below. 2 lobes above, 2 lobes below. So around this carbon oxygen sigma bond, the pi electrons lie. So the geometry will be trigonal. Geometry of carbonyl C double bond O, sp2 hybridization, trigonal planar, and the bond angle will be 120° approximately. Now the carbonyl group C double bond O, C double bond O group, this is carbonyl group. This C double bond O is polar. Why is this polar? Because oxygen is more electronegative, and this structure is in resonance with one more structure in which this bond pair electron will be taken by oxygen, because oxygen is more electronegative, so that the bond becomes carbon single bond O with oxygen negative and carbon positive. So we get a dipolar ion. Here this is the structure that is neutral, no charge separation, neutral structure. This is a structure that contains 2 poles, dipolar ion. Because of this resonance, C double bond O group, carbonyl group is highly polar. Carbonyl group is more polar than ethers. That means aldehydes and ketones are more polar than ethers. Ethers are also polar. Aldehydes and ketones are also polar, but they are more polar than ethers. This is due to this carbonyl group is in resonance with a dipolar ion. Hence, carbonyl group is more polar than ethers. Aldehydes and ketones are more polar than ethers.